So the next talk is n1tr0 talking about packers and crypters. Take it away.
Sounds good. So thank you for the introduction. This is packers and crypters of our current generation, and then what's next. So I'll describe a little bit about packers and crypters. We'll go into a little bit about what they're made of, how they're constructed, do a demo, and then we'll also kind of go into the what's next feature, which we'll talk about that. Who am I? Paul Streander, n1tr0 on the forums. I do red teaming. I also do exploit development, a little bit of reverse engineering when I need to find out new ways to do things, and then research and development. So why would you be interested? Well, I can only imagine that you like to find out a little bit more about a packer or a crypter. That's why you're here. You'd like to understand a little bit more about the PE header. The PE header is the golden goose of the file system that makes up our files on Microsoft. It also is how you manipulate the structure that's been defined by Microsoft to actually crypt or pack your system. Also, why do I care if my systems or if my packer is FUD? FUD's that dirty word, but we're going to use it here. It basically means that it's fully undetectable. It's the nice way of declaring that you've passed most of the virus engines that run on VirusTotal. And then what's the process to do that? How do I actually get something that bypasses all the AVs? We'll go through the demos, and then we'll wrap it up with conclusions. So, packers and crypters, here's our description. You can kind of stop me if you feel there's any difference here, but packers, they do more compression. They basically, they rip out the text segment and they try and slap everything in the data segment. They rewrite the way things are supposed to be done within the actual file itself. Then you have the crypters. Crypters are fun because what you do is you figure out a spot within the file, and then you want to obfuscate where you're storing something or pulling something down to actually encrypt data. Does one provide a certain functionality that it does, another doesn't? Most of the time, the implementation I've worked with in crypters, you can find that AVs will flag on the implementation of the APIs. So when you're writing one, APIs will be flagged on, and you usually want to encrypt the APIs even with a simple XOR, and then XOR your APIs you're using again when you use them. Renaming them or doing an actual a decal call, and then as just a different name altogether will actually solve that. So, does one benefit another? I guess you could say one is better. I prefer running crypters. Can both run together? You can. Those are more considered to be the protectors. If you look at the two of them running together, that's packers and crypters. And then there's another category altogether that take packers and crypters and then throw in antivirus evasion and a few other techniques like anti-debug, and basically trying to get past all the AV heuristics and malware analysts that would actually try and take your code and then run through it, pop out the malware altogether that you're trying to hide or obfuscate, and then also figure out what your stub file is. So your stub file is basically the clean file that you want to keep around or recycle through, and then figure out what kind of encryption you're using altogether. So why are these tools needed in security? Simply, you want to evade AV or any detection. That's mainly why a team would use it when going out on an assessment. And it's much easier to pack or crypt something than to refactor your entire tool set. So a little bit about the PCOF file format. The file format and what it's used for, it's the makeup of the files on Microsoft. The mirror of that in Linux is the ELF format, so there's packers for that as well, and it depends upon what you're actually trying to pack or dissect in the file format. Why does that assist in packing or crypting? Essentially, what you're trying to do is read through this file format like you're trying to read through an ICD. So if you're reading through an interface control document, you're reading through something for the very specifics on where memory is located, where you're supposed to write to, and what you're supposed to actually address to find the correct offset on where you're supposed to load the address on the PE header to load or grab anything for your file. Mainly that's what the PE header is used for, and we'll go into a little bit more information about that throughout the slide. Here's a quick picture of what a PE header looks like. As you can see, you have a simple exe, you have a header, you have sections, you have a DOS header. It's mainly seen to be in conjunction, starts with an MZ, but has been known to start with a couple other ASCII characters, human readable ASCII characters. Off the top of my head, I don't recall those, but I know that there's other variants. Then you have the PE header makeup, which is where your image base is designated. Then you have optional headers. They'll say that these are actually optional, but they're not. And then you have your data directories, your section tables, and then you start getting into where your actual code is located. For a malware analyst or somebody that's looking at code, your imports is probably one of the coolest portions to look at. Say you throw this into McAfee's file insight. You throw that in there, and then this just dumps out all the hex for you, and then I'll go through a picture on how that actually works out, where File Insight will drop it out and then list everything for you. In a second, I'll show you how the imports nicely align if not fully encrypted or obfuscated. And then you have data. You guys are getting pretty sticky with Mountain Dew. So we have here File Insight, a quick snapshot of that. This is just a TCP reverse connection that I encrypted and sent through an AV, and then expected to see call back to a backtrack instance. So all I did was throw it in a File Insight instance and say, okay, what shows up, where's everything thrown into, and then can I basically take a look at that. As you can see, it's got shell and two WSockets. That's basically what you're looking at. And then if we take a look at it even further with Resource Hacker, we now look at it and see, oh, it's masquerading as Apache. So it's essentially been packed, and the resource has been altered to make it look, even more of an appealing feature than you would normally look at it as before. Yes?
Do you find that, so take that file as an example, that AD would flag it on the modified sections? So I saw that in the previous slide that the data section
Yes.
is marked, I believe, on write execute.
I did not notice that myself, but if it is, then yeah.
Yeah, it just seems like something that they would key off.
Some do, and in this case, Microsoft did, MSE did not like this one. So this was done by, if I have this one, it'll be the next slide down, but this one was done by a commercial packer. And the commercial packer, you can't get into the guts because somebody already wrote the code, they zipped it up. Unless you want to try and crack something, if you're into cracking, this goes up there right up with, if you're a cracker, this is right up your alley. So where you dig into it, you try and toss things around. This one here, I just used a commercial packer, or it was actually a crypter, threw it in there, wanted to see how far it'd get, it did not pass MSE. And for another example, I'm going to use code that I found off of iCode and a few other examples that had been fairly useful in the past. And those have been useful in the sense that the in-memory execution is what you actually need to learn and how to launch a process within a process. So say you're running a Hello Ponies app that's just as like cool little ponies. And then from there, you actually start running your malware, or you're decrypting your malware, and then from that point, you decide to trigger it based upon a handshake or a key authentication. That's the essential gist that you'd want to do. In this case, I just threw together something and then tested it out and put it out there. For the initial POC, I'm actually doing a callback to a Metasploit instance. On this slide, why does it matter if they're FUD? Well, if you do this for a living and you're red team, it definitely matters. You want to make sure that everything you're putting into that bad binary that you want to send across to the other side evades the AV. You test it on all your AVs that you have already, and then you basically send it out the door. It's probably about, I'd say, at least a 4-step process, because first you've got your exploit code that you've already written, and that has to bypass the AV. Then maybe you've got your packer, and your packer probably has to pass the AV. And then you've got maybe your callback, and your callback has to pass. Well, in this case, if it's doing an in-memory, it might not have to pass the AV, and that's the point of the packer or the crypter. But you might have 3 or 4 steps that you actually need to check, and that's basically why you set up your own AV testbed. So FUD, it's a funny little word. It's also like the whole APT word where people don't want to hear it, but it's true. People do look for it. So we have here where you actually have static and dynamic binary analysis. Well, there's lots of tools to do that, or if you get really good at dissecting the PE header, you get better at looking at it and catching it on the fly. Process to achieving your FUD packer or crypter is basically making sure that you encrypt your data, you figure out some public-private key signing and exchanging your information. You do something with polymorphic functions. I've seen encryptors actually, or crypters actually set up the functions as a filler code. So you go through and you put more code in the actual stub than what actually belongs there. That's just one possibility. Another would be the allocation of, I'd have to find it. It's not on the top of my head, but there's one function call that 0 AVs like, and they're always going to shoot it down. But if you actually call it out ahead of time and call it something else, and then reference it as a different name, you're usually going to get past them. It's basically about customizing your stub. And then you can make it look like dancing ponies or an installer. My favorite is an installer that looks like you clone one. So you go out and find a bunch of installers you like, and you start cloning installers. You start pulling the resources from the installers, and you start customizing them. The only problem with that in fully cloning them is they're signed. So unless you have a way of pulling their signed certs and actually fully customizing that, then you run into some problems there. Here's a typical banner. This is what most everybody on there will actually try and say, hey, I'm 100% FUD, I can get past this. This is what I've tested on. This is why you should pay me for my crypter. The other funny is you've got people out there on Freelancer. They'll sell their time and they'll sell their expertise to say, hey, look, I can do this. go ahead, $120. I'll build a crypter for you, no problem. Right? This one just happens to be $578, but he's got his own Delphi compiler. That's about as much as I could buy a Delphi compiler for. So, you know, that's about it in that regards. So let's see if I set up pre-recorded because I knew that the demo gods spite you. And so here essentially is the first encryptor. It runs, it does its bit, and then it spits out the protected file. It's commercial use, but MSE, it caught it. So I rolled back my VM to McAfee. Well, it bypassed McAfee like a charm. So and here's that protected foo basically calling home. And you know, I don't have any cool music going along with this, or I'm not sitting there typing, but I didn't really want to have anything crashing on me at the same time. So this is where I head over to this one, and over here is where I set up the Metasploit Framework and started a listener, a multi-handler with and the do it script. All I'm doing is basically what you guys did in the beginning, created a raw, and just to see how successful I could pass it by, created foo.exe, which is what I encrypted earlier. And in one of the PowerPoint presentations I referenced later, this type of exe on VirusTotal gets picked up about 6 out of 32 times when encrypted, but when not encrypted, it's about 31 out of 33 times when encoded. So the fact that, yes?
How can you possibly not pick something like that up? Like from an AV perspective, is there any particular reason that if it's known bad code that's been like just really beaten to death, why there would be AV companies that still wouldn't detect it?
I don't work for an AV company.
So
I wouldn't know.
Fair enough.
Yeah.
I can give a little bit of insight on that world, in that a lot of AV companies, take McAfee for instance, are receiving on an average of somewhere between 30 and 40,000 samples a day, and then correlating that with the stuff that they have all over the world. It's a risk assessment. Okay, these are the things I'm most likely going to be dealing with, so they're only going to write signatures for the ones that have the highest potential detection, the highest potential infection rate.
Sure.
And the second thing where I think that's going to change eventually is more cloud-based AV and HIPs. So, you know, now you start looking at customers who are running things like Viper. I know for us on Pentest, you know, anything where they're going to take my exe and then upload it to the cloud, scary. Scary, scary, scary. You know?
Thank you.
I can see that as definitely an issue where I know Movix wrote the VT notify. That's perfect. I would love to use that style of reporting when I'm out on an assessment, just to make sure that incident responders have not already taken my binary and used it or alerted it to the VirusTotal at that point, because then I need to re-roll everything at that one instant in time. I need to go to the red team individual that is my POC, and then tell them, okay, have you heard anything? And then at the same time, I actually need to go re-roll a binary and then send it out to my operations team, which will actually go out and then send out something else, another phishing email, or even if they're in the system, use that to migrate through the system rather than the one that's already been detected. In this case, you have it's done. It's called back, and all I did was a simple get UID, and I have a Win7 demo with my username. So simply, this is the second crypter. This was found on Pastebin. This guy, he's a great coder. Well, I'll say he's a great coder only because he's the only reference I found for an in-memory file execution of 64-bit code. So and Metasploit's actually added his code into the reference for Mimikatz. So when you go and try and find any way to do the in-memory file, when you're trying to run something directly in memory, his code is the one that's actually being used most of the time. So I found his code because it's very clear. You can take a quick snapshot of his file code, and we'll go over it in a second, and search for it. And there's a whole Pastebin article of his file to mem function. You grab that, and so that's what I put together for the second crypter. Right, ran this one. It's now the second crypter. It's calling home. Same idea. Same notepad sketch here. It passes McAfee as well. Calls back as well. But in this case, now I didn't pay a commercial entity to encrypt anything. Now I just rolled my own off of Pastebin. So, and now I learned something about in-memory launching and how I could use my own stub creation and how I can take it even further to masquerade as something else and do a little bit more of what would I actually like to do if I created my stub a little bit more unique or characterized for the site I might be attempting to give a binary to. So that's essentially what crypting and packing is all about. It's masquerading the Trojan or the exe that you're actually holding here. It's not about 7-zipping something or even RARing something. It's about actually efficiently sending something across and then unzipping it without detection. Unzipping is a Blaine term there, but decrypting would be the correct one. So I set a couple stages up, and this one worked as well. All in all, conclusions. In my opinion, packers and crypters are a mainstay. Like, I see them used. I went through the effort of, like, I'd always seen a packer referenced on VX Heavens in assembly. Always wanted to figure out the guts of what did I need to do to create this in assembly, right? What was that? Until I actually went forth and learned the PE header, it didn't make any sense, right? You were looking at stuff that was a lot of assembly that referenced a lot of areas of the PE format in memory that you didn't have a lot of information on until you actually looked at the PE file format, and then you understood more of how that was being manipulated. Till I got into it and started looking at it on how the packers work and the crypters work and how you can manipulate that, then it made more sense. And now I think my goal is to more or less write in assembly and write smaller files, which would be where the files like the tiny PE come in to play, where you've got the really small files that are just a tiny bit of PE, the least possible that you can actually have, and then from that point you build onto it, or you do building blocks, and then you can put in your small cryptographic algorithms or what have you. Knowing this information, it allows you to benefit with your malware analysis, your rootkit development, or even packing and encrypting. So, just like in the beginning, what's the next generation? And so this is the audience to ask, is what is the next generation of our packers and crypters? And if we're playing a cat and mouse game with antivirus companies, and our tool sets are basically meant to avoid detection, what is it? And I put a few up there, but I'm willing to hear a little bit more feedback on this. So one I had noticed was the Meta ASM encoder. It's been done, it's out there, but that can be improved upon. There's always the polymorphic encoders and the metamorphic encoders. One I like is the cross compile, right? So I basically throw min-GW on there. I do some cross compile. I use wine, and I throw up a binary, and it's thrown up a binary that is similar to Windows, not quite the same, but it's not quite detected either because it's not one-to-one Windows. So that's one I had worked on for a little while, and it works in a sense, but there's other ways to do cross-compiling, and so I'd like to hear some answers on what other people think.
The cross-compiling for us has definitely worked. That min-GW compiler, we use that in May. You're using it as well?
Yeah, I actually do the exact same thing.
Yeah.
Casting shellcode and stuff like that so you can, like, we would take, Metasploit generated shellcode or something like that, and where stuff was getting picked up the most from where we saw was from the stub of wherever the payload is being generated from by Metasploit. So if you actually just take that shellcode and that changes 100%, and you give it the P by compiling it in GW or something like that, the evasion rate is
significantly
higher. It requires a tiny bit of effort and programming knowledge, but it's I don't want to say manual because it's not exactly manual, but it's because you're still generating the shellcode or it's
right
from somewhere else. But it's really effective, and as a pen tester, it works really well.
Right, it's much higher than just trying to do it on the normal Visual Studio,
Sure.
which would pop out a bunch of debugger symbols, Visual Studio, bleed, and everything else.
Sure, exactly.
Right. I've got a ton of references that point back to anything from DLL loading. Peter Ferry he's got a ton of research. Is great in this industry for this stuff. iCode is a great site. If you're always looking for just the basics, I think Microsoft has it. If you want to combine the two, you can do PDF packers. You can do kind of a thing where you're doing more of the PDF with JavaScript, Meta ASM, and then have that unpack into what you're looking for as a binary that would run on the other side. I haven't done that, but that's kind of something I'd like to try. Yes?
You mentioned that you got flagged on Microsoft Security Essentials.
Yes.
And I'm only speculating, but I would guess that the reason you're being taught so often is because Microsoft, considering it's their specification, they're going to be really good at parsing their PE format.
Yes.
And they obviously have a massive list of known good PE formats. Anything that might deviate from that, especially in obvious cases where you're messing with like the section headers. And also in the case of Crypters, if you're keying off of entropy, especially
you make a good point.
Especially in an executable section, then that should raise the red flags.
You've got a good point, but then if you also look at installers, so take a look at an installer. An installer just packs this. I'll reference Adobe's installer here right now. You can take Adobe's, which is all Flash. It's that Flash packed portion, which is in a resource file, right? And so you take this entire packed portion, which is a Flash file that you're not going to be able to run with anything that isn't supposed to run, except for Adobe actually runs it in itself as an exe when it actually compiles and runs. So it runs it in memory with the ability to do that too. So there's all the files that are legitimate, but actually emulate the same thing as a crypter or a packer. So you have to know what you're trying to imitate.
But then you can couple that with the reputation
Yes.
that the Adobe file is going to have. It's signed.
That's you just hit the key point right there. So if you step it up, if you really want to go the distance, sign your files.
I'm really curious about the DLL injection. Application whitelisting is really kind of coming in. I don't think we're seeing a whole lot of it right now, but for me, I really thought DLL injection was going to be the future of hacking. I really thought DLL injection, process injection is where it was going to be at. But now people are talking about this whole like trusted DLL loading and all that kind of stuff.
Right.
I'm curious, what do you think of the future of that in terms of cat and mouse game?
So when I was warned when I was doing this that don't try and inject in another process that's running. Keep your process space and inject into it, or try and escalate your privileges from there. And then by escalation, just call back and then do normal things that you can amongst the system. So if I'm a system that can call DLLs, and I've got a reference on here that actually can download a DLL, handshake for it across the network, saying I can exchange a key, pull back pieces across the network, you do obfuscation that way, and then run it from memory. Can I load DLLs that aren't supposed to be essentially loaded and then have some type of service or file running at that point? That would be a nice way of doing it. The only way I have it now with this example here is it's a bunch of information stored in a file that gets decrypted, right? So can you essentially, but if you're locked down, if you're in a sandbox even, right, you detect you're not in the sandbox, right, and if once you detect you're not in the sandbox, you shut down, right? I'm not gonna think about it like a device that needs to do a key exchange before it can even turn on or send the information, right? So if you think about it as a device that way, then you'll probably start conceiving on different ideas about how you construct your two receiving ends. So I think it's more about key management. So,
second question, if you don't mind. Let's say you're in a training scenario like my situation. I do a lot of training. So now you're trying to give a young developer challenges that can kind of introduce them to this world. What would be some of those little challenges that you could say, hey, why don't you go chew on this for a little bit, see if you can write something that can do X? What would be like a good stepping stone to get into this if you were a young budding developer?
So the one that was given to me was, here's a file, go parse this, go parse the PE format. Just a random file, just a given file. I want you to learn first the PE format, and then learn how Microsoft handles it, and then write code to parse it out, and then feed me back the imports, feed me back the data, feed me back the text, and then tell me what it looks like. So that you're basically writing a PE parser at that point. Yes?
Just wanted to address Joe's first question, where you're going to be getting into scenarios where they have really good security and they implement whitelisting solutions. And gradually you're going to see more malicious actors start to use legitimate processes as surrogates. So PowerShell is a great example. You could take a vulnerable signed binary and possibly exploit that and live inside that. So yeah, just leveraging known good signed binaries to act as your surrogate is what you're supposed to see.
Yes.
We repeated the whitelisting multiple times, bit9 and first stuff.
Do you have a list of APIs that are picked up by each different antivirus engine?
I don't have a list for all of them. I know the ones that I've used that are, that I've had to obfuscate. So I can put that out. I'm going to put out a list of the URLs for all the rats and information. Like I played with reversing Stuxnet, looking at that source. I looked at Zeus. I looked at that one for a little while. Then there was most of the Packers. I really liked compression libs for a while, because when I thought about doing my own Packer, it was what kind of compression library did I want to use to implement a Packer. And then while you're looking for all these things, you're also coming across how people would implement destroying the PE format in the compilation. So it's not destroying it, it's just reallocating it, essentially. and so you find all these tricks with the way people are doing it in the C code. So, and essentially, while you're looking over all these things, it enlightens you on different tricks of programming the source. And if you want to dig deeper, you can look at different assembly methods. One that I have referenced is I wonder if I have it here. Oh yeah, Tiny PE, one of my favorites. Yeah, it is. Yeah, but still useful. And then the other one, this one was fun. This API encryptor. It works. It's cool. Let's see, what about this one? Okay, there's this one here, this PE parser in Python. I would suggest if you were giving a task to somebody, if they only script, to basically do the same thing as the PE parser in Python. But if they really want to get to know it, is write the same thing in Visual Studio, essentially. And then you've got everything from simple packers to packer list. I mean, I put basically everything on here to anybody that needed to start from scratch to anybody that just needed a refresher. So, bless you. So, questions and comments, but then I think we're doing that now, so I'll just go ahead and put out thanks. So I've got thanks to Mark Carey or Forkus for setting me on the track of he's the one who basically would be doing what you suggested, is go parse the file. So, and then Peter Ferry's PE header description, he's got a great documentation on that. And then Steve, the fact that I searched high and low for just how to run in 64-bit mode, and that one segment of code is basically the one that is being used and is now in the Rapid7 repository as well. So this gentleman here, or lady, SigSegV, basically was my first implementation of the in-memory forking. And then QuarkAMI is basically a great resource when looking at PE documentation. And if you code in any Visual Studio or C, it's MSDN for the win. And that's about it. If you guys want to go through source, I've got the source file here. I can answer any questions afterwards, but and I think that's pretty much wrapping it up.
You got about 10 minutes. You got 10 minutes to keep going if you want.
Oh, if you want to look at source code or go over anything, let's see. So,
Have you built your own?
I have.
Okay.
Just a generic star. Have you built it? Yes.
Have you released it, or is it something
No.
you keep to yourself?
I keep that one.
Like saying encrypted traces quickly if you release it suddenly.
Sure.
Release date +1, right?
Yeah. Yep. So, this is the one I think I was discussing, is the virtual alloc is oh yes. Give me 1 second. Oh, okay.
Zoom buttons on left and right.
Zoom buttons on left and right. Thank you. All right. So this is the famous mem, or file to mem, and basically what happens here is if this is the correct one, yes, okay. So what you're doing is you're putting in a file name, and then you're launching that. I've modified mine a bit to accept where I'm putting it, or I'm taking a string from the file, because essentially I'm trying to encrypt a string and then put it out. But you essentially want to launch a file. So we'll quickly go down the memory or to main here, where it's being set up from. And then main here basically says, okay, I'm going to launch this, and this is where I want it to. I want to take this executable, which is now it's going to map the PE header from this executable, and it's going to launch it in memory. So then if this is PE file, I'm going to execute file with the PE file. And so the exe file is now basically what you're going to set up. So if PE file returns true, then get module file is basically all you're doing is grabbing the relative path name for that, and then from there you're taking the path name of where the file is and you're executing that file name. And the execute file name is basically where the magic happens here. So
this is not that much code. I mean, it's like mind-blowing.
It's awesome, yeah.
It's really, really short compared to what I would have thought, like the length of how long I would have taken to do what is being done.
Yes.
It's 100 lines of code.
Yes. It's wonderful. So here you basically take in the path of the file, and you take your pointer, your LP void pointer, which is your file pointer, and then from there you're going to take your file pointer and you're now going to build an image base off of this. You're going to map the DOS header off of that. You're going to set up your DWORD image base and then your pointer to it. This is the one that's funny. There's a little bit of information that's not quite in here in the yes. So I can tell you right now that this is just the function, because right here there's where some of the magic happens, where this NT unmap view section is getting renamed with a kernel call. So that gets renamed to X NT unmap. But then, and what you're doing is you're lining up your structures. And so if you wanted to start to get to know anything, you'd start looking at, how are these structures laid out within the actual MS-DOS constraints or format, and how is the DOS header and the NT header and the section header, how's that all laid out, and how's it written to, and what is the information that needs to lie there. So what happens is if everything returns true and everything lines up, the worst problem is when it doesn't, and you're hunting down memory errors or that wonderful 0C00005 crap, and then you're tearing apart your code trying to find out the error. That's when you write to problems where you're not supposed to. Otherwise, you've got alignment, and then when you have alignment, everything just falls into place. So then you align your NT header, and then from there you start aligning your DOS header, and you get your magic bits aligned. And then you're supposed to now create a process. And so you create, and I've seen people do this in different ways, where they've actually created a process with the flags set, or they've set it with null. So because, and then multiple authors have talked about this portion here with page read-write. So the page has to be read-write that you're actually virtually allocating, because you're setting up space that you're going to play with. Somebody ran into a memory error on the forums and just had it read, not read-write at one point. You'll shoot yourself in the foot in that case too.
So one of the key aspects there is that you're creating a process suspended, so that you can unmap its file representation and swap in.
And swap in the one you're doing?
Yeah.
Good point. Where, let me see, okay.
5 minutes.
The crease read write, or the optional header?
Line
52, thank you. Oh, where you have suspend as an option. Okay. So where you're actually taking the current process that you're running And the suspending. Okay. Yep. And then from there, I was following along as virtual exe, or I'm sorry, this one will define whether or not it's going to do a sorry, that is Unicode or not. And then so it'll pick for you with the image base, and then from the image base you can then write the process and then go from there with all the functions that actually set up the write process memory. And then you virtual free, and you've now set up the file. And that's about it. That's it in a heartbeat, and it works. It's actually really nice. The only thing that I would probably do different is
now he's gonna say like all
No,
this stuff.
go ahead and close it.
Yeah.
okay.
Here's the truth. Now that I can tell you, no one.
No. Not anymore. It's broadcasting.
Okay. So the only thing I would do each one is set up encryption that you can just roll through differently, and then also populate your. I've seen different encryptors basically give you that flood of, hey, I want to choose this, that I want to flood it with fake instrumentation of functions that just, okay, this function is going to do this, but it's going to look like it's real. Currently, if you encrypt data and it has, like you mentioned, high entropy. You've got so high entropy because your stub is so small versus your file, which is so big. So why not make my file huge with all the stuff I'm going to throw in there? There's just blank functions that do nothing, math functions, anything that actually kind of run. And then from there, I can cut down the amount of entropy, the randomness that's actually in the file. So that's, and then mix up, the encryption functions that you throw at the thing. Maybe use Microsoft's built-in encoders. That might be another feature. So, and I think that's about it.